Okay, in our previous video, we saw the grayscale spectrum, and we basically generated a synthetic pattern for grayscales. If you remember, that's the code for it. And we used NumPy and Matplotlib for that, and we saw that how the grayscales, the colors, they vary as you increase the number of levels of grayscales. In this video, we are going to talk about the real grayscale images, how to read those images from the computer, how to manipulate those images, how to treat the images as matrices, and how to write the modified images back to the computer. So, and for that we will be using, first we will be using Matplotlib, the same package that we use in our previous video. And I will also introduce another package for the same, for doing the same kind of stuff, which is known as OpenCV. So let's dive in. Let me just write here a heading. What we are going to do, we are going to do processing grayscale images. So that's what we are going to do. That's by the way, in Jupyter, if you want these kind of cells, there are multiple ways of doing that. One way is to go and select this markdown. There are different kind of cells. One is markdown cell, another is code cell. If you use markdown cell, you can write these kind of descriptions, and if you select code cell, then you can write the Python code in there. So, and there are shortcuts. If you, on Windows, if you, for example, press escape button and then press M for moon, for example, then you will be in the markdown. And if you press escape button and then press Y, then you will be in the code cell. We have explained all these, how to use this Jupyter notebook and stuff, in our full course on Python. We have a full Python course available on AI Sciences, so you can check it out to get to know how to play with, to learn the basics and advances of Python language as well as Jupyter notebook. So let's now locate an image. So I already have located an image, for example here, Einstein's image. So let's read that image. Let's copy the path and read that image in the variable im. So plt, that's from Matplotlib, plt.imread, and this R is for raw string. And here, if you press shift enter, you will be having your image available with you. Now this image is, if you, for example, check the type of this image, that's a real image. That's a NumPy array, NumPy n-dimensional array. If you check the shape of that image, that is this. So it has 949 rows, and which is sometimes known as the height of the image, and it has 728 columns. And further, you can check the type of that image, dtype, which in this particular case, each and every entry is unsigned integer 8. Unsigned because all the values, as you might have noticed, all the values, they are non-negative between 0 and 255, and this is a 8-bit image, and so it is an integer which is not signed, which means unsigned integer, and 8 means it takes 8 bits, which means the total number of levels are 256, starting from 0 and ending at 255. So that's our image. I can show you the image here. So for example, plt.imshow, that's a method, and you can, there are multiple color maps. So I can give the gray color map here, and here you can see the image, which is a grayscale image. Not only that, you can access different pixel values in this image. For example, if I just show you all the image in terms of a matrix, although the visualization in terms of numbers will be very bad, but let me show you that. So you can see that this is the image. Some of the parts of the image are shown here because the matrix is too large, and that is consistent with our explanation that image indeed is a grid of numbers at the end of the day. When you will call the function imshow, when you will display that corresponding to different colors, for example 85, whatever the color code is, that color is assigned here, and then depending upon what numbers are there in the image file, different colors are displayed here, which makes this a real image. Let me, for example, access the value at 23rd row. It is not basically 23rd row, it is 24th row, because the row numbering, the indexing starts from 0, not from 1. So 24th row, and let's say 300th column, and let me just get what is the value, what is the color code at that position, and at that position the color code is 70. Similarly, we can get color codes for different positions. So the position 24,301 is roughly like here. It starts from 0, it starts from downwards here. So the grid basically starts in this particular way. The normal convention is that's your row increase, and that's your column increase, and that's 0 0, which means if you go down and down and down, the row index increases. If you go right and right and right, your column index increases, and that upper left corner acts as origin. So this 24th row and 301 column will roughly stay somewhere here. That's 24th row, and 300th column might be somewhere here. So I'm pointing out this kind of pixel. Further, we can play with these pixels. For example, let me just go from position number, let's say 23, and I will go to position number, let's say 100 in rows. So that means start from row number 24 and go till row number 100 by not including the 100. That is standard NumPy indexing. Again, we have a full-fledged course on Python, so you can go there and understand how the indexing works. And then we have columns. Let's say we start the column with 41 column, and column number 41 will be indexed with 40 because of 0 indexing, starts from 0. And let's say we go to this, and we just place there 255, let's say, and let's see what happens, which means I have picked a patch, and at that patch I have placed a pure white color. So that's what I did. So it's read only. Why it's read only? Assignment destination is read only. Why is that? Can I not set the why is that? For example 23, 100. If I write this, that's read only. That's amazing. That's why don't I copy dot copy? Why don't I do that, and then I place, for example 23, let's say 100, and I place there, let's say 200, and everything works. Okay, so that means the original form, when we read in PLT in image structure, that is read only, but we can always play with that by using a copy, by taking a copy of that and then playing with that copy. So let's now do again the same command, but now on a copy of this variable. So let's do that. im2 And now if I just show you M2 with CMap gray, you will be noticing a white patch here. And as you can see here, there is a white patch here in this particular position. And not only that, we can assign different colors, different intensity values to different patches or different individual pixels, pure white, pure black, or any other color. Let's change another patch of this image. Let's say patch starts from 300, ends at, let's say, 400, and then let's say the column position is same, let's say, and let's change that patch with intensity value, let's say 100, which is some gray value inside. Now plt.imshow M2 CMap gray. If you can notice here, it is hard to notice, but if you notice here, that's a patch with same intensity value, and that intensity value is 100. Let's do that intensity value as pure black just to get it identified quickly. So now you can see this patch. And if you see, I'm just playing with an array and everything is happening with this particular image. Now let's save that image in computer, the modified image, which is M2. Let's save that in our computer. Let's say at this position. So let me copy the path here, Control C, and plt.imsave. The file name is this. Let's say modified. That's modified image, and the image data structure is M2. So let's save that. So it should have saved the image at that path. So let's see that. So it has saved the image in this particular way. We should have saved the image by using the color map gray as well. It has saved the image in a different color map. But either way, let's go and try to save it in the same color map. For example, CMap as gray, and if we now go and see, it's a grayscale image. Yeah, so that's saved here. So that's about playing with a grayscale image and treating the grayscale image just like a two-dimensional array of numbers. And one thing that we also saw, that if we just read the image in a variable using plt.imread, it's a read-only matrix, but we can always make a copy of it and play with that. In the next video, again, we will be I'll be moving on, and I'll be doing the same kind of stuff using OpenCV rather than Matplotlib, because in this particular course we will be heavily relying on OpenCV. That's a very powerful package for computer vision tasks. So I will introduce OpenCV for reading an image, for displaying an image, and for modifying just we did as using Matplotlib. We will do the same stuff using OpenCV in our next video. So hope to see you in the next video.